Hi, in today's video I'm going to be talking about non-polarized capacitor shield detector. I have done sort of video on exactly the same subject in one of my previous videos. I think it was one, I marked it as one forward slash. So you should be able to sort of, and I advise you to actually look at it because I went into a bit of a depth explaining what is a non-polar capacitor and so on. Nonetheless, what is a non-polar capacitor? Does it have a positive and negative as such? No, it does not. It lacks distinctive positive and negative terminals. But, however, it is polarity conscious. Due to the manufacturer, they do have a beginning and the end of capacitor in general. Capacitor sort of consists out of two metal plates with some kind of isolation type of thing. Okay, now they can be wound, all sort of three of them, two plates and isolation, circular manner, square and so on, or they can be sandwiched. One like that, the other one like that. Sort of, you know, it can be folded. So you do have basically the beginning and you do have the end of the actual non-polar capacitor, which now, if you look at it on this picture, which I have explained in a previous video, I call this particular terminal, and this is the actual beginning of the, if you sort of can visualize as the capacitor is wound in a circular manner or sandwiched type of thing. You can see that would be the beginning, and this would be the actual end. All the sort of windings are joined together, and basically that becomes like an outer layer of the capacitor. In other words, you got the say beginning and you got the end of the capacitor, and that end is actually the outer layer of the capacitor. So in actual fact, if you do not connect your capacitor in a proper manner, you will actually start picking up. In other words, say for example, if you want to ground the signal to ground, you know, via the capacitor, or coupled to different circuits, or many different sort of applications. If it is reversed, you might pick up, and more so, you definitely will, in very, very latest electronic devices and gadgets sort of made for past several years. And more so even right now, as the electronics becomes more complex and sophisticated and so on. So it is very, very essential for non-polarized capacitor to be fitted in a proper manner in order to avoid whether you're repairing or you're building the circuitry to eliminate the noise or Rfi-Emi, EMI from being picked up you know, by the capacitor or generated by the capacitor. So now basically I'm gonna go, and I have done the actual demo. I'm just gonna put this on the side here. In this particular procedure, which I have made it much more sophisticated, I'm not gonna go into the details, what I have done, etc. and so on, but there is a distinct difference. Now, I basically now, between the first procedure and this procedure, and it is 100% accurate. I have, in order to obtain the simplicity and because of customers' demand, I need speed and I need the accuracy. So I have automated the whole system, my own sort of way, and I haven't seen anybody sort of done it more or less in this way, where I have also involved okay, I can't turn the camera right now, but on that side, you can see on the pamphlet, you can see actually, you can see the setup over here, and it's connected to my instruments over here, if you look at it. And I have automated, so I can do in a jiffy, as they say, where's the positive, where's the negative, so-called positive, so-called negative, or the outer shield more to explain. Or should I say beginning and the end of the actual capacitor, non-polar capacitor. So all these capacitors, I have done the tests and so on, and 100% accurate. Nonetheless, as I said, I have got already one capacitor here. You can see it. I've just chosen, say, that small one. Now I have got a special little antenna that I have designed it and made it for this particular purpose, so it can pick up properly the actual noise, and I can accurately actually, I'm trying to find the words, so I can accurately sort of pinpoint where's the shield and where's the sort of beginning, where's the start of the capacitor. Okay, if you look at it over here, instead of reversing the capacitor physically, I'll just toggle the switch and I select positive over here, or I select positive over there. So wherever the switch is turned, that would be the positive, in other words, beginning of the cap, and the other leg would be the actual end, or the actual shield. And then what I do is I take a cocky pen and just mark the capacitor, so I know where is my shield or the negative of the non-polar capacitor. All right. Now on that note, basically what I do is, the basic difference is I'm feeding now the proper signal from my bench, as I explained, and I showed you pictures just now, and I can vary the actual signal from like 1 hertz to whatever frequency I want. And the reason why I'm doing that is because depends whether it's a big capacitor, something like this, or even much bigger, or something like this, or it's that size, or it's this size, or it's a surface mount. They do behave differently, and they got different sort of their own resonant frequencies and so on. So in order to obtain perfect measurement and 100% accurate, what I have done basically is I'm using different frequencies, and I'll tell you now how I'm going to actually do it. So now it's already coupled, and then of course with the antenna that I have, as I said, designed for this specific, goes into my signal tracer. A signal tracer is a device which has got extremely high input impedance and very high gain, and I can vary the gain over here plus what you call it, and I can use also the actual frequency from it, but I decided to integrate my whole bench into the measurement, which I'm not really displaying over here. I'm just showing you the final results on a signal tracer. But nonetheless, basically I connect the capacitor, and then already maybe you can hear the tone. What I do is I put it, say, to 0 dB as my, and then what I do is I toggle the switch where I'm going to obtain bigger reading. Okay, now, so the bigger reading is over there. Okay, so which means now I'm going to find my 0 point on the higher reading. Okay, so I put it there. Now, watch now when I toggle. Can you see it over there? Now, it is reduced basically to something like 4 decibels less signal this capacitor is generating, or sort of receiving, let's put it that way. In this case, I'm actually generating the noise through the cap, and I'm picking it up of the antenna. So, but it works both ways, receiving or generating, emanating from the actual capacitor. So now I'm just going to toggle it again. So right now that's my positive. Okay, because my positive signal is coming to that particular, as you can see on the switch. Now you can see it over there. That means this one here is positive and that is actually negative. So what I do is now I remove the capacitor, I take a cocky pen and I put a little dot over there, and that is my let me just zoom. I don't know if you can actually see it. Okay, I'm not gonna try to actually zoom it. The reason why, because it's difficult for me to operate a camera and try to do the explanations. But nonetheless, I have, in a jiffy, I have determined, of course, if I don't want the noise, I can just switch off the generator just to the VU meter. Let me take this big capacitor and see what happens there. Okay, now I'll just put it here for stability, so there is no movement. I'll just clip it. Okay, let me just switch off so it doesn't make a noise. Now I take my special antenna and I just put it on top of the capacitor. And there you go. Now, okay, let me just, now I can vary the frequency and I can see where I'm obtaining. Okay, I'm gonna put it over there. That is more or less where the capacitor radiates the best, or is susceptible to noise the best. Now if I toggle, you can see I have something like about 10 dB. Now 10 dB, that's quite a substantial amount of possibility of this capacitor that I'm just testing picking up any sort of interference or any noise and so on. In other words, and also it won't generate any noise picked up from surrounding circuitry and things like that. Alright, so you can actually see it. I'm just gonna do it one more time. Okay, right now it's connected, say positive is over there and my negative is over there. Okay, so that's actually wrong way, because you can see the switch is pointing over here, and wherever the switch points, that is the actual positive coming from the generator. So now I toggle it and you can see it's less than 10 dB. Sorry, just over 10 dB attenuation. Okay, now let's do next one. Doesn't matter which capacitor I put, I will get 100% accuracy. Let me try this small one. Let's see what happens. Doesn't matter whether it's a small or big or whatever, the procedure is the same. So now I'm just gonna do this. Alright, now as I said again, let me toggle it. So that is my higher, and now I'll just play around with the frequency. Okay, so now I get more or less resonant frequency of that capacitor. So now, because it's transmitting the sort of most of the actual signal that I'm sending into it. So now let's try it again. Now you can see the switch is in that direction towards red. So that means that is positive and this is negative, because the switch indicates the actual in what direction. Is it this direction? That would be positive. If it's in this direction, that direction, that is positive now. But now I'm getting the least signal, so when it's in this particular position, and knowing that the switch is indicating my positive, that would be my negative. So what I do is I take and I'll just label the actual cap and I just put the dot. And now I know where my negative on that particular capacitor is with 100% accuracy. Alright, now what else can I do? Okay, let me try this one here. Let me try actual one. or let me try the actual one, doesn't matter. Okay, let me just bend the legs. Okay, you can see it. I put my special antenna on top. Okay, and again, okay, now I just zero it in. That's where I get the highest. Now I play with the signal applied. Okay, I'll leave it there. Okay, that gives me 0 reference. And right now, positive is over here on this side of the cap. Now I toggle it, look at it over there. Now positive is over here. So that is my negative. Okay, it's negative. And I'm getting about minus 8 dB between a wrong way connected in the circuit and then the right way connected to the circuit. In other words, that is my negative terminal. So again, what I do is I take and I put a little dot. So now in actual fact, if you look at it over here, let me remove this cap. You can see over here they put like a marking. And one would assume that that is the sort of end or the actual shield, but it's not. As I've just shown it over here, as I marked it, where actually the end or the shield or the negative, if you would like it, to be called or whatever. Okay, so now let's do one more. Let's do, what can I do? Let's do Wima. Wima is the world manufacturer, renowned manufacturer of capacitors. Let's try it and see. Okay, I connect one leg there, and I have no idea which is positive, which is negative, but I will find out now. Okay, you put it more or less in the center of the cap. Okay, now I obtained my 0. Let me put it there more or less. Now I'm going to vary the frequency quickly just to see where I'm going to get the... Okay, I'll leave it there. Okay, now 0 it again, and I use it as a reference point. Now positive is over here, according to the switch, because it's on this side. I'm just going to toggle it. Now the switch is to that side, Look at it there, something like minus 11 dB attenuation, which is like something like 100 times less noise that you will pick up or generate if you connect it up, the right way, type of thing. So, yeah, on that note, I think I have done the quick demo on the actual procedure, and as I said, it is very fast. I'm just doing it slow because I'm talking and I'm trying to sort of use the and sort of do the actual demo. So on that note, I hope this concludes, unless I come up with some kind of other innovation or my own way of speeding up or getting some other sort of things that I have not had a chance. Oh yeah, one thing that I'm busy right now with, as I said, on some surface mount capacitors, I can also measure. I have done it already, but it's a bit difficult because of the time that it will take, and I haven't made a jig as yet, and I cannot use my special isolated tweezers because that would influence the actual capacitance and things like that. So I'm just really making a jig that I can just insert and then slide, and it will hold the capacitor, and then I just put again, as in the jig, I would put whatever, and then I will be able to display and determine the actual where is the outer shield, or where's the beginning, or where's the outer shield, or where's the positive, where is the negative, so-called, if one could call it. Yeah, on that note, basically, I thank you for watching. Of course, I've got tons of different capacitors in stock, but I'm sure you get and you grasp the concept of what actually we are doing. And as I said, with my jig and some other jig in between the generator and the actual instruments that I've got over there and the signal tracer, I get 100% results. So on that note, till the next video, I say ciao.